One of the most striking properties about light is that it has color. To understand the phenomenon of color, it helps to think about light as a wave. But before we get to that, let's talk a bit about waves in general. Imagine you're sitting on a boat in the ocean watching a cork bob up and down the water. First thing you notice about the motion is that it repeats itself. The cork traces the same path over and over again, up and down, up and down. This repetitive and periodic motion is a characteristic of waves. Then you notice something else using a stopwatch. You measure the time it takes for the piece of cork to go over its highest position down to its lowest and then back up again. Suppose this takes 2 seconds. To use the physics jargon for a second, you have measured the period of waves that cork is bobbing on. That is, how long it takes a wave to go through its full range of motion once. The same information can be expressed in a different way by calculating the wave's frequency. Frequency, as the name suggests, tells you how frequent the waves are. That is, how many of them go by in 1 second. If you know how many seconds one full wave takes, and it takes easy to work out how many waves go by in 1 second. In this case, since each wave takes 2 seconds, the frequency is zero point 0.5 waves per second. So enough about bobbing corks. What about light and color? If light is a wave, then it must have a frequency, right? Well, yes, it does. And it turns out that we already have a name for the frequency of the light that our eyes detect. And that's called color. That's right, color is nothing more than a measure of how quickly the light waves are waving. If our eyes were quick enough, we might be able to observe this periodic motion directly, like we can with the cork and the ocean. But the frequency of the light we see is so high, it waves up and down about 400 million times a second that we can't possibly see it as a wave. But we can tell by looking at its color what its frequency is. The lowest frequency light that we can see is red, and the highest frequency is purple. In between all the other frequencies forms a continuous band of color called the visible spectrum. So what if you had a yellow pencil sitting on your desk? Well, the sun emits all colors of light, so light of all colors is hitting your pencil. The pencil looks yellow because it reflects yellow light more than it reflects other colors. What happens to other colors like blue, purple, and red light? They get absorbed, and the energy they are carrying is turned into heat. It is similar with objects of other colors. Blue things reflect blue light, red things reflect red light, and so on. White objects reflect all colors of light, while black things do exactly the opposite and absorbs all frequencies. This, by the way, is why it's uncomfortable to wear your favorite black T-shirt on a very sunny day.